Bienvenue mignon. Nous voici at Nick Does Maths. We are picking up today a super cool question that was left over on the LUNGANG subreddit. Go check it out. Some really cool maths questions on there. And I saw it, I was like, I have to get this down. I have to try this question out. So we've got some absolutely horrific second order differential equation here. That's terrible. We got lungs, we got roots, we got like powers of 5 over 2. However, there is a hint for us, and by which is a full-on signpost. Let's use this transformation. We're going to go from x to t. X is e to the 2t to get this all of a sudden much nicer linear differential equation here, second order. Okay? And then we're going to solve it, obviously. So how does this work again? I'll remind you, I'm going to do a lot of the transformation down here, then we'll do the solving over here. Now remember, what we want to do is we want to get an expression for dy dx. And in fact, before we do this, actually no, dy dx, no. I know this is going to come up. I as well smart like that. Where's my blue? This is going to come up. Let's just differentiate that quickly. dx dt is 2e to the 2t. It's going to be important for us in a sec. Right, so dy by dx, a bit of chain rule tells you that is dy dt, dt by dx. But dt by dx, if we just flip that, that is 1/2 e to the minus 2t dy by dt. Okay. Well, what that means is d2y dx squared is d by dt of dy by dx times by dt by dx. So differentiate this with respect to t. So this is a product rule. So differentiate that. I get minus e to the minus 2t dy dt plus 1/2 e to the minus 2t d2y dt squared. Keep that, differentiate that. And then times by my dt by dx, which is 1/2 e to the minus 2t. Now, here you might be in your right to say, why, Nick, would I do this? This doesn't look like it's going to make my life any better, but trust me, it will. If I multiply this out, I get minus 1/2 e to the minus 4t dy dt plus 1/4 e to the minus 4t d2y dt squared. Okay, because what I'm going to do now is I'm going to take this expression for d2y dx squared and whack it back into here. Now, so I end up with 4. Now, x to the 5 over 2. Take that to the power of 5 over 2. I get e to the 5t. So that's nice. Times this. Minus 1/2 e to the minus 4t dy dt plus 1/4 e to the minus 4t d2y dt squared plus 2. Now root x will be e to the t, y, actually that's just there. And again here, we're going to be tight. Root x is e to the t. Ln x is 2t plus 5. Might be a bit of glare over on that side. We'll try and bring it back down over here. Now if I multiply all of that out, because I've got a bit of a shocker here, bit of stuff to tidy up there. Excuse me. What do I end up with? So 4 times minus 1/2, I will end up with, there we go, a little bit more space here. Minus 2, e to the 5t, e to the minus 4t is e to the t. 4 times 1/4 is just 1. E to the 5t, e to the minus 4t, I get e to the t. d2y dt squared plus 2 e to the ty is 4t squared e to the t plus 5. And what are we going to do across the board here? Let's divide everything by e to the t. If you do that and rearrange it, we will get what we wanted, which is d2y dt squared minus 2 dy dt plus 2y is 4t squared plus 5 e to the minus t. So part 1, done. I love me a good change of variable. It's absolutely incredible how by doing this, you think it's going to be worse, right? Because there wasn't a dy dx term here, and all of a sudden I've got a dy dt. But by making this very, very innocuous change of variable, all of these horrible terms that are knocking about have just gone bye-bye. How would we know to do it? Well, not entirely sure. The key might be there with the LUNGANG. We try e to the t, and it doesn't quite work because not everything cancels out, so we then try and fudge it. There is a certain art to solving differential equations. This one is just really cool. It's just really, really cool. I'm not fanboying over it at all. You are. Right, now let's solve it. We solve the homogeneous one. Characteristic equation, lambda squared minus 2 lambda plus 2 is 0. That solves for lambda is, that's lambda minus 1 squared plus 1. So lambda is 1 plus or minus I, which tells me that my complementary solution is y is e to the t a cos t plus b sine t. Which is going to be horrible right at the end, because of course I'm going to want to rewrite everything in terms of x, right? And by and large, we're going to have to do something down here, and I'll solve that in a second. Right, now I need to deal with the right-hand side. Now we're going to try, I've got a quadratic, so at squared plus bt plus c. I've got some e to the minus 4, e to the minus t, so e to the minus t. There's no conflict of interest, no resonance there, so I can just crack on. dy dx is 2at plus b minus de to the minus t. d2y dx squared is 2a plus de to the minus t. Now let's plug all of that back into here. So I end up with 2a plus de to the minus t. Minus 2 times that, minus 4at minus 2b plus 2b to the minus t, plus twice that, plus 2at squared plus 2bt plus 2c plus 2d to the minus t. Now what has that got to equal to? Well, it's got to equal to that. Let's get some colours. So first things first, let's match up the t squares. So 4t squared, boom, 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 bosh. That's the only place I'm going to get those. That tells me that 2a has to be 4, therefore a is 2. That is an arrow, it's not my best arrow. Okay. What else? Let's look at the t's. Well, where have I got t's? I've got some t's there and I've got some t's there. So that tells me that 2b, or not 2b, sorry, 2b minus 4a. There are no t's in the right-hand side that I'm looking for, so that's got to come out as 0. So b is 2a, so that gives me b is equal to, ow, therefore b is 4. Let's look at the terms without anything at all. 2a minus 2b plus 2c. And again, that should cancel out. 2a minus 2b plus 2c has to be 0. So that's 4 minus 8 is minus 4 plus 2c. c is 2. And then finally, looking at the, that should be a D, shouldn't it? And finally, we look at the e to the minus t's. d, 2d, 5d needs to equal to 5. So d is equal to 1. Okay. So let's put all of that together. And I'm going to use this side here. We end up with y is equal to e to the t, a cos t, plus b sine t, plus 2t squared, plus 4t, plus 2, plus 5e, plus just 1, e to the minus t. That is my general solution for this differential equation. Now, I need to plug a bunch of stuff into here. I'm not going to write it all out. It is absolutely abysmal. But we can get a few key things in here. If x is e to the 2t, we know that e to the t is square root of x, so that's quite nice. What else do I need in here? E to the minus t is therefore 1 over root x. And unfortunately, there's a lot of t's to plug into here. So t is ln of root x. And then if you want to make yourself really, really sad, you plug these three things into here, and we have our solution. Awesome. I'm a big, big fan of these types of things. Really quirky question, out of nowhere, not sure what exam board or anything like that it comes from, just an absolutely brilliant use of a change of variable to solve a differential equation. Awesome. I hope you enjoyed that. Don't forget to drop us a like, a subscribe, hit the bell so that you don't miss these as they come out every couple of days or so. Let us know what else you want to see. Post your questions over in the LUNGANG subreddit. It's a great place to chat to other people about further maths and complicated, interesting rather, maths as well. Brilliant. I'm Nick, and I will see you next time.